Hello, everybody. My name is Christos Goros, and I am an API architect at Postman. For those of you living under a rock, Postman is a platform that helps people build, use, and collaborate on APIs. But in this talk, we're going to focus on how we do things internally in Postman engineering. More specifically, we will go over the areas of API design, how you can manage API design at scale, how we utilize a platform and engineering approach, and open source tools like OpenAPI and Spectrals. Finally, we will go over test examples of what we are testing for compliancy on API design. First of all, did you know that Postman has an API of its own? Postman's public API exposes everything that you can see in the UI in a programmatic way, like APIs, collections, workspaces, monitors, mocks, and so on. My work as an API architect is to help Postman API users to integrate in order for them to enhance Postman capabilities so that they can create their optimal tooling, or they can embed Workman, they can embed Postman in their workflows. To do that, I study why our users may need an API, what functionalities are they seeking beyond the core product, what they're trying to achieve, and finally, how they're trying to do it, because that's equally important, right? What tools they have in their arsenal, and what is their way of thinking. Some common use cases are automating how Postman resources are getting created. So create everything that you need in a workspace so that a team can start working on Postman right away. Ensuring that everything in Postman has the proper structure, has the proper naming convention, and the access policies are correct. So access between teams is only in a team workspace is only available to its team members. And finally, tool integration, like tools like developer portals, CI/CD, or something that a lot of people into testing will find familiar: test planning, test analysis, and test reporting tools. My goals for the Postman API are that it is simple to use, really good at what it does, and makes it easy for its users to achieve their goals. Through that, drive adoptions and eventually increase its usage. But for all that to work well, we need good API design. What does good API design mean, you may ask? Some common elements of a good API design are descriptive names, names that are descriptive and align well with the API's goals and what the different entities do at Postman. Users that are able to do what they need to do in order to succeed, like, for example, filtering with certain attributes. Payload formats that are flexible and they evolve well over time without causing existing users' integrations to break. And last but not least, clear error messages, which are very important while troubleshooting. Without all these elements, the experience can be pretty bad, right? I'm sure that all of you have encountered bad designed APIs that cause you a lot of frustration. But you may argue that all these things are obvious, and that a lot of teams are already practicing, discussing them, and involving it in their day-to-day API design and development. But we have another problem to solve, and that's scale. And scale refers to scale both in our systems and also our organization with multiple teams involved. Because chances are that if you're working for a bigger company, you're going to work with a distributed system and multiple teams maintaining and developing it. Postman is such a system as well. So it has the UI, the web client, and the desktop client that you are familiar with. And its backend consists of multiple internal services, each one responsible for the equivalent part in the product that you see, like collections, workspaces, mocks, monitors, and the new Postbot service, which is quite awesome, by the way. And all these services have APIs that that they expose. And these may be APIs that serve the UI or APIs that are used for internal communication between them. Some of them APIs need also to be exposed to the public. And that's where the Postman API and my team, the Postman API team, come into play. So Postman API is a vertical layer that bundles internal endpoints that needs to be exposed to the public and makes them available to our users. Right? We follow the API gateway pattern. An API gateway component is a common pattern these days for API exposure. And briefly, some of the benefits that an API gateway provides are common authentication between all the APIs, common security, for example, API key or two, throttling, so that the requests that are coming to the API are up to a limit, so that there is no abuse there, and of course, more advanced routing, right? Routing requests based on different conditions like headers, parameters, content, and so on. And of course, all these services are run by different teams. Teams that consist of developers, testers, product managers, and all these teams have different timelines, different priorities, want to deliver as fast as possible. On our side, as the API, Postman API team, we want to have a common look and feel for the API. It really needs to be a unified product rather than just a mix of different internal endpoints that we expose on the outside. So, let's recap. What do we need? We need good API design. We want consistency at scale across different teams that need to work with autonomy so that they can deliver software and APIs the fastest possible. In order to address all these challenges, we follow a platform engineering approach. And platform engineering is a buzzword these days. It means different things to different people. Let me define how what it means for us in the Postman API team. Right, platform engineering means creating tools that other teams within your organization can use so that they can do the work simply, fast, and without knowing all the complex details. In this case of exposing APIs to the public. And that's what we've created. We have created a tool that team members can visit, and they can choose which of their internal APIs is exposed to the public. And on our side, we run a series of tests in order to insist that these APIs comply to our API design guidelines, to API design style, and contribute to the API as a unified product. We also run further tests like security tests and other things. But in order to do that, we need a way to describe the APIs, right? We want to test something before it's actually deployed. We need to describe how the API looks like in order to test it. And for that, we are using OpenAPI. OpenAPI is a standard format that allows you to describe HTTP APIs. It allows you to declare metadata on your API and its version, its title, what it does. And then you can move on to describe the paths, then the URLs that it exposes, the parameters that these support, the methods like get, post, put, paths that exist, and what response users should get for each one of them. 200, 400 for one unauthorized, 500 for a server error, and of course the content formats that these responses include, like fields and their types and various constraints and options around them. So given that, our testing is practically reduced to creating rules and validating them across the structure of the OpenAPI JSON and YAML documents. And we could do that with manual code, or we could use other JavaScript and YAML linting tools. But we have gone with a tool that is targeted towards OpenAPI documents, and that's Spectral. Spectral is an open source tool that out of the box allows you to verify that an OpenAPI document has correct structure, it has all the necessary fields, paths, and everything inside it is as it should. And on top of that, it also gives you the ability to create your own custom rules in order to test specifically for your API design style. Here's an example of a Spectral rule. In this example, we have a query parameters camel case rule, and it will check all the query parameters in the OpenAPI description and check them that they are in camel casing, and that do not contain digits. Otherwise, the test will fail. So if you combine all these things, back to our diagram, you can see that what teams actually do is that they go to our platform tooling, they submit their OpenAPI descriptions, and the OpenAPI descriptions drive the whole process. The OpenAPI description has all information that is needed for routing from the API gateway to the internal services declared in the OpenAPI. Information like parameters and of course security, what type of security model the API should have. They can set rate limits, how many requests per minute, how many requests per a team should be able to run against the OpenAPI. The whole process is driven by this OpenAPI description. And when submitted, we are testing it with Spectral rules that pretty much can characterize our API design style. In a sense, we have codified it, our open design style, with Spectral, and we are validating each OpenAPI document against it. If the test pass, the endpoints are deployed to our API gateway, and this is done automatically via the API gateway's own admin API, without any manual code involved. We can also do more things with an OpenAPI descriptions. You could also generate code, but in our case, what they're doing is that we're using it to generate documentation that is later merged to our public Postman workspace. Let's go have a look at what some of our the rules look like. Contact information. We require that each OpenAPI description submitted has a name of the team that is submitted the API, an email, and a Slack channel ID. That way, we can communicate with the team if needed, and we can also send them notifications about the process, about if the exposure process is working well or if it encounters an error. Right? We also that way create an ownership map, pretty much defining which endpoints of our public API are owned by each team. Semantic versioning. We want each of our APIs that are exposed to be versioned with following a semantic versioning approach. That means on the right, having a major, a minor, and a patch version. But the really important thing here is to have one unified system, right? And not follow any custom version strategies like on the left. That way, we can consistently evaluate and update on a given endpoint and run further tests upon what's updated in the given test, in the given endpoint. Let's go to some more tricky ones. Resources are always plural nouns. So let's say that we want to expose an API about spacecrafts. The resource name should be plural, so spacecrafts, instead of the one on the left, spacecraft. And this is a bit subjective, so we find that the plural best describes the collection operator. So when you get spacecraft and you get a list of spacecrafts. But the important here is to choose one thing and stick with it. Again, we also don't allow verbs, and we believe that you should be as simple and as lean as possible in your API design, and we don't really need verbs, right? Launch, like launch in this case, adding verbs to your API design increases its orthogonality, which pretty much means that that's a concept from programming language, and it means that it increases all the possible combinations and what your user needs to learn. So we don't allow any new terms apart from resources and their IDs in our API paths. And you can always design your APIs in order to fit those criteria. Similarly, we don't allow resource nesting, right? That's another term that introduces complexity in our API. What does having account transfer mean, right? Not really. You can either model it as one entity like account transfers, and of course, we allow hierarchies like account that has an ID, a specific account ID that's linked with a set of transfers on the right. Another case of promoting consistency is that we only allow camel case in our parameters. So these are query parameters or path parameters. But in any case, on the left, it's a spacecraft dash ID. We will throw an error for that. We want all our query parameters to have camel casing like this: spacecraft, capital, ID. And again, the important here is to choose one option and go with it. That way, you can achieve consistency across 10, 20, 50, 100 APIs. Date format. Date format is one of my favorites because it's not about the structure of the content, but it's about it's the structure of the JSON format, but it's about the actual value, right? But OpenAPI can also help you define that. So on the left, a date that is just a number will fail. We demand all date values to be in date format, and specifically ISO 86.1 format, which is a pretty good format both for reading from humans, but also standard so that it can be easily parsed from machines as well. Collections must support pagination. Again, given that a lot of times data are available to our users, but they cannot access them because they do not have the functionality that they need, like pagination or filtering. In this case, we demand that if you have a collection endpoint, in this case spacecraft, that returns a list of items, it will always have an offset and limit, which means that it supports normal pagination, like page size and pages. You have a table of results, and you go to the next page in this table, or cursor pagination, which is something more similar to what Twitter has. That you see a list of tweets, and by scrolling down, you infinitely get more results as you go. Similarly, if you have a collection endpoint, you always need to use a query sort parameter, pretty much so that you're able to sort data, for example, with the creation date or the name of the person that has created them, right? Again, make the information accessible to the user through added interactivity features. This one is not about design, but it's about the documentation that we produce, right? We demand all parameters, and we also do that for objects as well. We demand all parameters to have examples, right? A given value that is representative of what the value will actually look in the real API. That way, the documentation that we generate is much easier to understand with examples. Version in pubs, right? This is also very important because we're not exposing the endpoints individually. Our public API has a version path of its own, right? And it acts as a unified thing. So we cannot expose internal version details to the public. Any API that needs to be exposed needs to avoid any details about its version. And people also have the tools available in our in our platform in order to change the URL paths, and they can hide internal versions if there actually are. Error format. Now that's another very important thing, right? In this case, if somebody selects to add their errors in, let's say, an error in the code field, we will throw an error. We do not want users to have to parse multiple error formats. Every error should be handled the same way. That way, in order to achieve that, we define the problem details error format, which means that the content will have a problem flat JSON content type. It will have a type string, which acts as the type of the error. It will have a title, which is a human readable title for the error, meaning what it does. And we have a detail field explaining further what happened in order for users to troubleshoot. These were some of the the most common errors that the tests that we have set. Uh, we have more than them, and you can also expand this type of test in order to check for security as well. For example, check that you're not exposing any basic authentication endpoints. Creating this set of tests had its challenges, right? The first one of those challenges was that if you are writing your tests in a JSON or YAML format, you actually have to test that the configuration that you created is correct, right? So we had to actually create test framework on top of our tests that pretty much had valid OpenAPI descriptions for its test and invalid ones, and actually test that each one of them pretty much produced the proper result. And this is something that will further expand as we discover edge cases, as more APIs are exposed from our teams. Some things are hard to test even with Spectral. Like, for example, how can you test that the names are descriptive? This is something that it's up to our opinions, but perhaps in the future, AI can help with that as well. Re-evaluating tests. So as described, our approach is to take the API design that we want, codify it into Spectral rules, and then test for it. But the style is not static. I did not decide one morning what the style would be and starting applying it and enforcing it, right? If an engineer has an idea that they have come to for the public API, like for example, they want to implement a query language so that they can search a resource with more fine-grained criteria. It's something that we discuss, we manage the pros and cons, and then eventually we'll update our API design style. And each one of these decisions in one of these changes needs also to be reflected in the tests. So in order to achieve that, pretty much we have created a streamlined process that every change creates a ticket. Through that ticket, we're creating a document, design what the change to our style needs to be. For example, the addition of a new query language. And when this ticket is resolved, pretty much it will always produce a pull request towards our Spectral rule set so that it can be represented in our testing. That way, we're tracking the evolution of our API design style and ensure that our tests are up to date with those changes. Finally, a constant change around APIs, and of course, of any API designer, is design depth and breaking changes. Some of our older endpoints are not compliant with our style, but because they were created before the system was set in place. And in this case, we can do a lot of things. We don't have a lot of solutions because we have existing users, and if these endpoint change, this will cause the existing integration to break. Breaking changes in general is something that should always be in our mind, and any update both to our APIs but also to our API design style should always consider what the impact will be for existing consumers. Now, now that we learned all these things and how we at the Postman API team handle our public exposure, what can you do in order to utilize what you learned? You can figure out the API design style that you need, or you can also start small with some security best practices and some documentation best practices. You can create spectral rules to codify them, and you need to find a point in the critical path of the delivery in order to inject your testing, right? Especially with API design, if you leave the testing as an afterthought, like something that needs to be testing after the API has been delivered, or if it's deployed and someone checks about it and pretty much um, creates a report about its compliancy, I guarantee you that it's going to fail. Like compliancy with our API design styles needs to be blocking, right? In our case, for the public exposure, it's pretty straightforward, right? Anything that needs to be exposed gets checked, and if it does not, it gets blocked. But similar practice can also be applied to internal endpoints and other workflows, right? Of course, another thing is that you have also to enforce the use of OpenAPI. This is not as hard as it sounds because nowadays most web frameworks and also can generate an OpenAPI definition that your teams can use. And there are also tools that can produce an OpenAPI an output. For example, Postman collections can be transformed to OpenAPI. That's something that we use a lot within Postman. We create and design and we test using our collections, and then we create an OpenAPI out of it. Then all you need to do is actually implement your compliance testing. Thank you.